Welcome to MEI Modelling with Algorithms. We're on the topic of algorithms, sorting, packing and complexity of algorithms, and this is video 1.4, sorting algorithms. So a sorting algorithm will be used, for example, if we want to sort a list of numbers into ascending order, or a list of words or other items into order. We might do this, for example, because we need to do another algorithm, like the first fit algorithm, where first fit decreasing algorithm, where that is used. There's one sorting algorithm that you need to learn, which is the Quicksort algorithm. But there may be other sorting algorithms that you'll encounter, but these will always be described to you in detail in the question. Now, the Quicksort algorithm is called the Quicksort algorithm because it is generally more efficient than some of the other common algorithms that you might meet. It works by choosing pivot elements and then arranging the numbers in the list either side of that pivot depending on whether they are smaller or larger. And in this spec, what we always do is to choose a pivot as the first element in each list. So this is the algorithm itself. Let's have a read through this. If it doesn't make complete sense yet, don't worry, it will do when we see an example. So the first thing that we do is to select the pivot element, and as we say, that's going to be the first element in the list. And then what we do for all the other numbers, we look at them in turn and see whether they are smaller than the pivot or larger. And we'll write down all the numbers that are smaller in one sublist to the left of the pivot, and all the numbers which are larger we'll write down to the right of the pivot in another sublist, but those numbers themselves will maintain their order from the original list. Once we've done that, we've got these two separate sublists, we'll apply the algorithm again to each of those and so on until we've got lists that only contain one number. So let's see an example of quicksort being used. So we take the first element in the list, which is the 5, and that's going to be the pivot. So we'll write down the pivot. I'm going to take a guess, an educated guess of where it's going to end up, and I'm going to put a circle around it there. And then I'm going to take every other element that I meet and write it either to the left or to the right of the 5, depending on whether it's larger or smaller. 8 is larger than 5, so that has to go to the right of it. 3 is smaller, so that's going to go to the left. And actually what I can see then is that the rest of these numbers are all larger than 5, so I'll write those down. I'm just maintaining the order of that list there. So what we've done is we've divided this list into two unequal sublists. This sublist on the left only contains one number, and if you remember from the algorithm, once we've got down to one number then we can stop. So I don't need to do anything else with the 3 anymore. All I need to do is look at this other sublist, starting with this 8 going along to that 6, and I'm going to now apply the quicksort algorithm just to that sublist. So let's take 8 as our pivot, and we'll write down the 8 there, and let's circle it just to make clear that's the pivot. And then 12, obviously that is larger than 8, so that will go there. 11 is also larger than 8, that goes there, as is 15. 7 is smaller, so that can go there, and 6 is also smaller, so that goes there. Again, maintaining that order. So now I've got two more sublists either side of the 8. Start with this one. I need to make 7 the pivot. I know it might seem a bit strange with a list so small to talk about the pivot, but 7 is going to be the pivot. There's only one other number which I can see is smaller than the 7, so that can go there. And then for this other sublist, 12 needs to be the pivot for that one. So let's write down 12, circle it. 11 is smaller than 12, 15 is larger than 12, and now all of my sublists are only one number. So I'm basically done. Let's just have a look at what we've got and write down the final results. So that's 3, 5, 6, 7, 8, 11, 12, 15. And that's in ascending order as required. Now, one thing you're often asked to do, as well as carrying out an algorithm, a sorting algorithm, is to say how many comparisons have been made in each step, because that gives you some indication of how much time this algorithm is going to have taken. So if we think about what happened in this first line, we didn't have to do any comparisons to choose the pivot because we always choose the first item in the list. But after that, all these other numbers had to be compared with number 5 in order to decide whether they were going to go to left or right. So that's 1, 2, 3, 4, 5, 6, 7. So there were 7 comparisons made at that stage. Then for the second line, there were we only had to deal with that list on the right. 8 was the pivot. All of these numbers that were put into these places were done so by comparing them with the 8. So that was 1, 2, 3, 4, 5 comparisons there. On this line we had 1 comparison there to put the 6 to the left of the 7, and then 2 comparisons here either side of the 12. So that was 3 comparisons there. And then we were finished. So that was a total of 15 comparisons when we carried the algorithm out there. So we mentioned that there may be other sorting algorithms that you'll have to use, but these will always be given to you. Here's an example of one. If you want to pause your video for a moment and read through it, and let's try carrying this out. Now, the first pass, this is going to be our first sort of line or our first piece of working that we do, asks us to compare the first and second items and swap if necessary. So let's underline these 2 items so we can see what we're working with. We're putting this into ascending order. Clearly these are the wrong way round at the minute, so let's arrange them in the correct order there. 2, 4. So after our first pass, our list looks like this: 2, 4, 8, 3, 5, 9. Alright, so let's just indicate here that that there was the working for our first pass. For the second pass, we're going to start by looking at the second and third items. So we're starting by looking at these 2. We ask, do they need to be swapped? Well, actually the answer is no, they're already in the correct order. And if we read this carefully, it says if a swap has occurred, then we'll go and look at the first and second items. But because we didn't swap, we stop at this stage. Alright, so after our second pass, the list is actually still the same as it was after the first pass. Like that. Alright, and then we're on to the third pass. So we start with the third and fourth item. They do need to be swapped. And because we've done a swap, we move to the second and third item, which are this 4 and this 3. They need to be swapped as well, so we'll swap the 4 and the 3 like that. Because we did a swap, we're going to look at the first and second item, so that's the 2 and the 3. They don't need to be swapped, so after the third pass, we've now got this list: 2, 3, 4, 8, 5, and 9. Alright, so that was the third pass. Now if we keep going, the fourth pass, we're going to start by looking at the fourth and fifth items, so that's the 8 and the 5. They do need to be swapped. So I need to then look at the third and fourth item, that's the 4 and the 5. They don't need to be swapped. As soon as I don't need to do a swap, I then stop. So after the fourth pass, my list looks like this: 2, 3, 4, 5, 8, and 9. And then finally, for the fifth pass, I need to look at the fifth and sixth item. They're the right way around already. I don't do a swap, so I stop there. So after the fifth pass, the list is the same as it was after the fourth pass. Now, having completed the algorithm itself, we're now going to be asked some questions about what's happened. So we're actually being asked to analyze the algorithm in some way. So one question we might be asked is, how many comparisons are made on this second pass? So if we look at what happened on the second pass, that's where we compared the second and the third item, compared the 4 and the 8, and we decided not to swap them. And because we didn't swap them, we didn't do anything else. So that was just one comparison there. Another question we might be asked is how many comparisons and how many swaps are made on the third pass. Okay, well there was more going on then, wasn't there, on the third pass? We compared the 3 and the 8, and we swapped them. Because we swapped them, we carried on going, and we compared the 4 and the 3, and we swapped them. And again, because of that, we compared the 2 and 3, and we swapped those as well. So we actually made 3 comparisons. Now what about actual swaps? So we swapped here, didn't we? We swapped the 3 and the 8. We then compared the 3 and the 4, and we swapped the 3 and the 4. Then we compared the 2 and the 3, but because they were the correct round, we didn't swap them. So we actually only made 2 swaps. So that concludes sorting algorithms. The next video will be complexity of algorithms.